Okay, so now we're going to talk about chemical reactions. This is usually the pretty exciting thing about chemistry. You bring two things together, something happens, and they produce something new. Okay, so what we have is we have an example here of some reactants, zinc and iodine. Actually, the zinc is probably the silver stuff over here, and the iodine is purple. They both have different chemical properties. One's silver, one's purple. You mix them together, you get this purple smoke, but you get some kind of a product which is a combination of them put together. And notice they are combined in a whole number ratio, just like Dalton was talking about. I'm going to erase all the ink on the slide. So I have 1 atom of zinc, 1 atom of zinc, 2 atoms of iodine, 2 atoms of iodine. And they've come together in a 1:2 ratio. Okay, so that's what a chemical reaction looks like. In a chemical reaction, what happens is the bonds between the outermost and the outside of the atom are broken, and then they reform new ones. Matter's not created or destroyed. All it is it's just rearranging. Okay. Often you get changes in matter. Okay. It changes color. It produces heat. Changes, phase, that kind of thing. You get new properties and energy changes. Heat. That's where it gets either hot or cold. Symbols are letters that represent elements. They can have subscripts, but they only have one capital letter. Formulas describe the compounds. That's what you guys have just spent a long time learning how to do, is how to take those words that describe these chemical compounds and writing them into formulas. So it's almost like you're learning, this is the vocabulary. These are the letters. This is your vocabulary of chemistry. And a chemical equation is like the sentences. We're putting together the chemicals, and they're going to create a reaction, and they're going to make something new. So if these are my words, these are my sentences. Okay, parts of a chemical reaction are important to know. You're talking about reactants. Those are the things that you start with. They're written on the left side of the arrow, since we read left to right. Doesn't matter what order they're written in. So if I had H2 plus O2 and then the arrow, it's the same thing as if it said O2 plus H2 and then the arrow. Okay, those are my reactants. They turn into the products. Those are the ones that are on the other side of the arrow. And again, it doesn't matter what order they're written in. Okay, so you can write them either order, doesn't matter. They have a plus sign that separates molecules that are on the same side of the arrow, on both sides of the arrow. And then they have an arrow that separates the reactants from the products. It goes reactants, arrow, products. And if there's more than one, then it's reactant plus reactant. Goes to product plus product. Can't quite fit that all in there. Okay, so an example of one that looks like this is the sentence. Solid carbon reacts with gaseous oxygen to form gaseous carbon dioxide. Putting it into a much shorter form, C representing carbon, that little S means solid, plus means reacts with oxygen. Remember, oxygen is one of our diatomic elements. That's a gas. To form, that's my arrow, carbon dioxide. Remember writing formulas? And it is a gas. So this is a whole lot easier than that. Whole lot easier. Saves you a lot of effort. Reactants are carbon and oxygen. Product is CO2. Okay, some of the symbols you might see. S is written in parentheses for a solid. If it's a liquid, it's written with an L. I usually do an L like that, though. Gas. Then there's this thing called aqueous. That means it's dissolved in water. A catalyst is sometimes written over top of the arrow. You probably won't see that very often. And if it's heated, they will sometimes put a little triangle over the arrow. Again, you probably won't see those very often. Okay, so chemical equations deal with the thing called the conservation of matter. Matter cannot be created or destroyed. It's just rearranged. That's the big idea. And why isn't it turning? In order to make that happen, we have to balance equations. And that's what this lesson's all about, is how to balance equations. You must have the same number of atoms of the same kind of element on both sides. Okay, they're just rearranged differently. So if I look at this one, what I see is that little 2 on the subscript on hydrogen indicates that it's a diatomic element. Same thing here. Okay, water has a formula of H2O. This number in front of the H2 is called a coefficient, just like math class, like 3x, the 3 is the coefficient. And it shows that it takes 2 molecules of the hydrogen to react with 1 molecule of oxygen. Again, 1 is understood. And it makes 2 molecules of water. That's what it means. To maintain conservation of mass, if I counted just my atoms, I have here 4 hydrogen atoms. Over here, that number multiplies, and I get 4 hydrogen atoms. Here, I only have 1 molecule, but I have 2 oxygen atoms, and that 2 distributes. Over here, I have 2 oxygen atoms. That makes it balanced. Okay, so how to balance equations. Best way you want to do with this is practice. You have to learn all the little tricks of the trade. When you are balancing them, the only thing you can mess around with is the coefficients in front of the compounds. Never, ever change the subscripts. That's like a huge, big mistake. If you change the subscripts, you change the chemical. The subscripts are determined by the name and type of the compound. So, for example, H2O, perfectly safe to drink, right? If I change this to H2O2, that's hydrogen peroxide. It won't taste so good going down. Okay, so subscripts versus coefficients. The C by itself means 1 atom of carbon. The O means 1 atom of oxygen. O2 means it's a molecule of oxygen combined. And this is the way oxygen exists in the real world. It's diatomic. It's one of the Brinkelhoff gases. CO means it's a compound of carbon and oxygen bound together to make a molecule of carbon monoxide. CO2 means you've got a carbon and 2 oxygens combined together to make a molecule of carbon dioxide. And if I have a 3 in front of that, that means I have molecules of CO2, CO2, and CO2. I have 3 of them. Each one of them has 3 carbon atoms, carbon, carbon, or each one of them. The total is 3 carbon atoms, and it distributes to make 3 times 2 oxygen atoms. That coefficient multiplies when it distributes. So the 4 basic steps for balancing equations is write the correct formula. That is absolutely the most important step, and people skip it all the time. You want to write the correct formula. You're not going to have to do that first, but starting with the next lesson on 6.2, you're going to have to write the formulas, and that's probably the hardest part. Then, don't balance it. Get the formulas correct first, okay? Then, you're going to find the number of atoms for each element on the left side. Obviously on the left side of the arrow. You want to compare it to the same element on the right side. And remember, subscripts multiply and coefficients multiply. Determine where to place the coefficients in front of the formula so that the left side has the same number of atoms as the right side for each element in order to balance it. And then check. Please check to see if the numbers of atoms on both sides are now balanced. Because sometimes when you change one, you change somebody else. So you got to pay attention to that. Okay? The coefficients need to be in the whole lowest possible whole number ratios. You can't use fractions. Because you can't really have half of an atom of carbon. You know, it's just not possible. So they have to be no fractions. Okay? There is no particular order you need to go in. It's not like you need to go left to right and do all alphabetical order or something like that. There's no right or wrong way to do this. It's more about getting the answer at the end. Okay? Here are some helpful hints. Take it one element at a time. I go left to right just because that's easiest. That's the way I read. Okay, but there are some other little tricks that I have. I sometimes leave hydrogen and oxygen for the last and balance everything else first, because these guys, hydrogen and oxygen, are sometimes written in more than one place as a reactant. So like you'd have H2O plus CO2. The oxygen's in 2 different places as a reactant. Makes it difficult to balance. So sometimes I save those guys for last. And then if I'm going through and I'm like, oh my God, everything works except I've got an odd number of something. Well, if you've got an odd number, the way to get rid of it is double everything. And then it'll work. So if everything balances except for one lousy odd numbered element, I would go through and double everything and try again. Okay? And then sometimes, and once you get good at this, you can consider the polyatomic ions that are on both sides of the equation, consider them as like an independent unit. And I'll show you how that works too. So let's do some practice. All right? Ignoring the picture, going left to right, I see I have 1 Al atom. That S doesn't count for anything, so you might as well just ignore it. 1 Al and 2 Als. Remember that 2 multiplies here. So I need to put a 2 as a coefficient to multiply that one. Then I'm looking at my bromine, and I see I have 2 Brs. Over here I have 6 Brs. I need to make the bromines equal. That means I need to multiply this times 3 because 3 times 2 is 6. Okay, and that's what these pictures are showing. Here's your Al, Al. These are all your Brs, and they combine together to make that thing. Okay, so pause the movie for a second. Actually, you know what? I think I'm going to do this one. 4 carbons, 1 carbon. Remember that 2 is only applying to the O. So there's only 1 carbon. I'm going to put a 4. I have 8 hydrogens. Well, normally I like to save H and O for last, but that's all I got left anyhow. So I got 8 hydrogens. Over here I have 2. So I'm going to put a multiple of 4 in front because 4 times 2 gives me 8. Okay? Now the oxygens. This is why I save oxygen for last. If you notice, it's here and it's here. The coefficients multiply and distribute, but when there's a plus sign in between, they add. Okay? So what I have is I have 4 times 2, 8, and 4 times 1, 4. So I have a total of 12 oxygens on the right-hand side. To make the oxygens on the left balance, I'm going to put a 6 there, because 6 distributed is 6 times 2 is 12. Okay? You guys can pause the movie, go ahead and do this one, see if you can do it. Okay, 6 carbons, 1 carbon. Put a 6 here. Don't forget, it distributes 6 times 1. 12 hydrogens, only 2 hydrogens. I'm going to put a 6 here, because 6 times 2 is 12. Then my oxygens. I have 6 times 2 is 12, plus 6 times 1 is 6 is a total of 18. I need to have 18 over here. That means this needs to be a 9. Remember, this is understood to be a 1. Okay? All right, see if you guys can do this one. Again, I would save oxygen because it's written in more than one place. I'd save it for last. I see no hurry. Okay, so for this one, 4 Bs, 2 Bs, I'm going to put a 2 here. Remember that 2 distributes. I have 10 H's. I need to put a 5 here, and again, 5 times 2 is 10, and it distributes. So, now I need to do my oxygens. 2 times 3, distributing, multiplying, 2 times 3, 6, plus 5 times 1, oh crap, now I've got an odd number. Well, you know what I'm going to do? I'm going to erase this number, and I'm going to turn it into a 4. I'm going to erase that number and turn it into a 10. I'm going to double everything. And I'm going to double this one, because remember, I've done something with this one. It had a coefficient of 1, so I'm going to give it a coefficient of 2. So let me erase all the ink on the slide. So I'm going to double this one. This would have been 4. And this would be 10. So now everything got doubled because I had that odd number. But I distribute just like I did before. 4 times 3 is 12. 10 times 2, 10 times 1, 10. That gives me a total of 22. Put an 11 there. Okay, so doubling the odd number sometimes helps. Doesn't always, but sometimes. Okay, so that one. All right. Go ahead and see if you guys can do this one. Now look at that. I see oxygen freaking everywhere. Okay, skip the oxygen for last. Do everything else. Okay. So I see 3 NAs and I see 2 NAs. Odd numbers. I'm going to double. That gives me 6 NAs. So I'm going to put a 3 here because that gives me 6 NAs. And that 2 distributes to the P. I only have one of them here. Remember that 4 is only in reference to the O. So I have 2 P's, so I'm going to put a 2 here. Now that gives me 2 FEs and 2 FEs. So my FEs are balanced. Look at that. Sometimes it works out nice. Now we got to do the O's. We've done everything except the O's. So I'm going to erase what I have because there's a lot of arrows in there and I get confused by all that. So I had 2, 3, and 2. So to do my O's, you got to account for everything. If they're on the same side of the arrow, they add together. So I have 2 times 4, 8, and I have 3. Over here, I have 3 times 1, 3, plus 2 times 4, 8. Oh, look at that. They're equal. And sometimes that happens, particularly if you save it for last. All right, see if you guys can do this one. I'm going to erase the ink on the slide. So pause the movie. See if you can do it. Okay, so 3 carbons, 3 carbons, 6 H's. Put a 3 there because 3 times 2 is 6. Doing my oxygens, I have 6 plus 3. Crap, odd number. All right, so I'm going to change those numbers to a 6 and a 6, and this one to a 2, because remember, it was a 1. 12 plus 6, 18, make it 9. Okay? And that's the end of the movie. So the best way to get good at this is to practice, practice, practice.